Um, so I'm going to speak a bit about what an Oracle developer does. We actually do the work of taking a customer's requirements for data and translating that to their contracts on chain. Just by a show of hands, I'd like to know how many in the audience are developers? And keep your hands up if you are blockchain developers. You've tried developing on blockchains before. Okay, thank you. So this is the agenda that I have planned out for today. We're going to discuss the Oracle problem. There's going to be some overlap with what Charmelin laid out. And then I'm going to go over how we can address the Oracle problem, or at least the way Rhombus has chosen to do it. And lastly, we'll go over some applications. Okay, so there are a lot of barriers to mass adoption of blockchains. Oracles are one of them, but let's just go through and zoom out. User interface is definitely an issue. A lot of times when you use blockchain-based applications, you get like wallet addresses, and the average user will be like, what is this random string of like hexadecimal like figures? I don't know what to do with it, and they'll exit. There's waiting for network effects. There are a lot of apps that someone who's developing is choosing between a centralized platform and a decentralized blockchain. And they're like, well, there's millions more users on the decentralized situation, so why would I take the risk of developing on a blockchain? Then there's speed of transactions and number of transactions. These are just scaling issues that we have to solve if we're ever going to be available to the average developer. And then this is like the focus that I want to go with today, integration with existing systems and data. That's where if we can't connect to the outside world, then the only application that we can actually do on blockchains is cryptocurrency. That would be the only useful thing. So like, this is a random quote that I like called "Paradise is a walled garden." And why would I bring this up? So paradise literally means walled garden, for instance. This is like an ancient Indo-Persian word. Parai means to build a wall, and dis means around. So in ancient times, they used to build these really nice gardens and put a wall around it and say that's heaven on earth. This is a situation that could describe blockchains today, because you basically have this thing that works if you follow the protocol and don't let anything in or out. Then you can assume that you have your paradise. But the problem is the applications are limited. So that, in essence, is the Oracle problem. How do you solve the issue of getting data in and out while not compromising? So there's the world. Here's blockchains, and we have the wall. What we want to do is replace the wall with essentially a moat with bridges across it. I chose the Golden Gate Bridge because I'm based in San Francisco, but it's like just my way of having fun. That's just what an oracle is. Why do we call it an oracle? It's a confusing term, right? Because anyone outside the industry, or even people in tech who don't know much about blockchains, think of Oracle, the company, and it's like totally confusing for them. So an oracle is like a priestess from classical antiquity. So people would journey to see this woman in the center. They would ask her a question, and she would do some, magic, if you will, and divine a response. She would tell them something about the future, about the condition of the world that they didn't know. And then they would go back to normal life and use that information to act on it. So hopefully blockchain oracles are not that magical, but the idea is the same. Oracles are sort of this conductor of information that allows applications to develop and be useful. But that's actually not the only aspect of the Oracle problem. There's also the problem of defining truth. And here's some motivating examples. What is the price of Ether in USD? That would seem to be an easy question to answer, but actually, if you go to any given exchange, you'll get a different exchange rate, USD to Ether. So if an application needs to know this, there has to be some aggregation, and that aggregation has to be defined by the client, right? It's sort of not up to the Oracle developer to say, here's the price of Ether in USD. So we have to work with clients to say, okay, you want the price of Ether in USD from these 10 exchanges. Now, how do you want to take the average? Do you want to take the median? How should we sort of normalize this for you? And then, we mentioned weather examples, at least Shyamalan did. So if we need to know what is the wind speed in Colombo for a smart contract to execute, that's not a simple question either. It's like, where in Colombo are you talking about? That's another aggregation issue. And these are actually relatively simple, but if we get unexpected information from an oracle, a smart contract might give you unexpected results. So it's important to carefully define what sort of truth you're looking for. And this is a tougher example in the same domain. How many clouds are in this photo? It's an image processing problem or a neural networks problem. But it depends on how you train the algorithm. So how do we address these sample issues? Well, that's basically what Rhombus is setting out to do. Why are we calling it Rhombus? It's a nice shape, it's got 4 sides, we have 4 pillars. You can easily flip it and play around. But basically, we think oracles should have 4 pillars. Rhombus has 4 sides. I'm going to go into how we define each of these things. But first, let's talk about terminology, because I think if we don't have common standards for how we discuss, then we won't really be understanding each other. So I think this is pretty basic for everyone who is already here, but I'm just going to go through it. It's the most word-heavy slide. So smart contracts and decentralized applications are programs that are stored and executed on blockchain. Oracles are basically data feeds for smart contracts and dApps. They tell a smart contract what happened in the real world, and then smart contract will use that information however it was programmed to. Rhombus is an oracle provider, which means we build oracles. And here's an example used in a sentence. Rhombus built an oracle to send the price of gold to a smart contract that allows people to purchase and settle call options. All right, now I'll go through the 4 pillars. I'll try not to make it a shameless plug, but accuracy can only be defined in the context of what we discussed earlier about the nature of truth on blockchain. An oracle can only be as accurate as it is consistent to the process defined at arriving at a result. Computability is actually really important. Although things like Stellar and Ethereum are aiming to be a decentralized backend for tons of different applications, there's a cost to a lot of computation on chain. So as much as possible, it is helpful to developers and ultimately reduces the cost to users if as much computation can be done off-chain. That goes hand in hand with security. So if you're doing a lot of things off-chain, you need to be able to show provenance. Where did the data come from? And then what did you do with it to arrive at the result that ended up at the client's smart contract? And lastly, dependability. Data has to be delivered on the schedule defined, right? If you have some enterprise-grade application in finance or insurance, it's hard to imagine not receiving a response when you request one. But actually, this is the state for a lot of Oracle providers today. So it's an evolving requirement, and people basically address it in different ways. One way is we'll send a result. If we do send a result, it'll be right, but we can't guarantee it. That's sort of on the software library end, like Oracleize. And then what we try to do is do this contractually through SLAs, guaranteeing certain response rates. Part 3, okay, I'm just going to go through a couple different people who have built applications depending on Rhombus oracles. So I referenced this earlier with the call options for the price of gold. Essentially what happens in this open law application is that a user opens up the decentralized application and they see that we've sent them the price of gold as it stands currently. And we also say, you can, if you want, buy the option to purchase the price of gold at another price. So let's say we're sending the price of gold is 10 Ether today. In 24 hours, you have the ability you can buy the ability to purchase gold at 11 Ether or above. So the user 24 hours from now, having purchased the option, can open up the app, see the price of Ether, and then decide to purchase. And in both cases, today and tomorrow, they get the price of gold from Rhombus. Then there's actually my favorite application possibly is a decentralized insurance issue with Hurricane Guard. Basically, these founders of Hurricane Guard are from Puerto Rico, which was hit pretty hard by 2 hurricanes in 2017. And what they saw was a huge broken insurance system for people who had paid premiums but were not being reimbursed by insurance companies for their damaged homes. So payouts were either smaller than expected, late to come, or in some cases never even came. Because once you pay an insurer and an event happens, they're incentivized to keep as much money with themselves as possible. So parametric insurance on blockchains tries to solve those issues by essentially having customers who are purchasing insurance pay money into an escrow account on chain. And then when a qualifying event happens, like a hurricane in this case with Hurricane Guard, the money is actually paid out upon verification of an event. So Hurricane Guard built these complex models to measure wind speeds on the ground when hurricane events happen, and they transferred over this computation to Rhombus and said, we want you to be in charge of delivering wind speeds, and we want the minimum viable information. So even though they built these complex models, what they really wanted was, should a payout happen? And this achieves the objective of minimizing expensive computation on chain. So for example, if in the last 24 hours, wind speeds on the ground reached above 111 miles per hour, that would classify as a Category 3 hurricane, in which case Rhombus would send to Hurricane Guard a signal that says, pay out everyone in this radius who has been paying premiums for a Category 3 hurricane. The stages of getting data to a client smart contract can basically be broken down into sourcing, computation, and delivery. So I talked about proprietary customer data when I talked about Hurricane Guard. But also we can use best-in-class APIs or audited data warehouses. So there's examples of all 3 there. Computationally, things can be as simple as an aggregation function, like taking the median of a bunch of temperatures, or as complicated as you want. In this case, let's say a farmer buys crop insurance, insuring against too much variation in temperature across his fields. In this case, we can basically calculate variation using this Shannon information entropy formula at the bottom. And you have basically millions of data points that you're processing over time. And you really take the burden away from the smart contract developer by really only sending when payout is necessary. So if this entropy in the satellite images goes above a certain threshold, then we send the signal to send the payout to the client contract. And lastly, there's a delivery phase. So we talked about prediction markets, Sharmalin did, and Gnosis, Augur is another really well-known one. They only need a one-time signal, like who was elected president for this particular election. Then there's a periodic delivery, like with OpenLaw, for the price of gold. And lastly, there's a conditional delivery. I'll go into that use case next. So in this case, Maker wanted to know the price of Ether in USD in order to basically run it's basically a bank, right, on chain. So they need to know what's the price of Ether, and in this case, they wanted multiple sources, they wanted Rhombus to do an aggregation, and they wanted the delivery to be periodic. So what happens is we go to the list of exchanges there in code. I think there's 6 in that screenshot. And then we throw out outliers, so anything 2 standard deviations from the mean we throw out, and then we take the median of the rest. So we go from like this to this histogram and then send the median, and we only send that if the price has changed by more than 1% in the last 10 minutes. So every 10 minutes we send a price if it has changed by a significant margin. So if you wanted to use Rhombus, we have a lot of docs up on the site. We're on mainnet for Ethereum, and we can actually deploy on any chain. We just have to establish one node on that chain. So actually, yesterday we launched with enterprise private chain system called Kaleido. They're a competitor to Hyperledger, if you've heard of it. And basically what we do if they engage with Rhombus is establish a node on any private chain that needs data sent to it. And then we can deliver in two ways. One is called a lighthouse contract, in which we basically deploy a contract on that chain, and we send updates to it, and any client who has access to it can call a function and retrieve the value that we've stored in that contract. The other method we have is direct delivery, where we don't launch a contract on a chain, we just send directly to the client's smart contract. And here are like some things we've been thinking about to make this more developer friendly. One is to actually take variable arguments. Right now, we deploy contracts that update with basically the same function call every time. It's like if you only needed to make one type of request to any given API, then you can find that in a Lighthouse contract today. But we'd love to be able to take variable requests with variable parameters. The other goes towards what Shyamalan addressed as a trust issue. He talked about having multiple data sources. You could have multiple Oracle service providers. Here's another option. You can buy risk-neutral feeds in which you're not only paying for data, but you're paying for insurance on that data. And then lastly, we'd love to develop zero-knowledge oracles in which the oracle doesn't know the content of the data it's processing on. It simply does the calculation and sends it. Sometimes this is called homomorphic encryption. We'd love to combine that aspect with oracles. It also should be used for any sort of sensitive financial data, in which case you don't want the oracle actually knowing what it's working on. So here's some links that you can go to find us. I'll see if we can send these out. And I'll leave this up in case you guys have questions, or if we have a Q&A session coming up, that would be good too. Thank you.